Okay. So today what we're doing, read the title, because the title's not up here on the board. So what does the title say we're doing? Oh, man. Okay. Writing rational equations from graphs. From graphs. Thank you so much for being thorough. Okay. So we're writing rational equations from graphs, which means that we're creating the functions. And we're creating them just by looking at what we have in the graph. And we're going to have to identify some of the pieces in the graph in order to write the functions. The functions, since they're rational, are going to be in the form of a what? Fraction. Good. These are going to go on page 84 when we're finished. So I'm going to jot that down in the corner here. Page 84 whenever we're finished. You're going to be happy to know that there is no homework today. And I didn't pick up any homework today, so that's fantastic. You are going to have, you are going to have a class assignment tomorrow, and whatever you don't finish is going to be due the next day. So when you see homework due on Friday, that's what it is. It's what we're doing in class tomorrow. It's whatever you don't finish. Okay? Yes, ma'am? Not relevant. All right. Not relevant. So in the top problem, it says use the graph to write the formula for each of the following rational functions. So before we even write anything, I want to go through and I want to look at the graph and pick out the pieces that are important. So what are some important things that you can pick out from a hyperbola? Yes, ma'am. Absolute. The asymptote what? What do you mean the same? As the intercepts?
There's one around the intercept.
Well, I know that I need to find the asymptotes, right? So take your rubber band. I want you to stretch your rubber band horizontally. So horizontally. It's not going to break unless you break it. So don't make that decision. Stretch your rubber band horizontally so that your partner can see. Lay it flat on the bottom of your graph and move it up until it becomes an asymptote for the hyperbola. Once it becomes an asymptote for the hyperbola, you need to figure out where that asymptote crosses. What number does it cross at? It crosses at 1. So that hyperbola has a horizontal asymptote right here. It crosses through halfway between 0 and 2, which would be at 1. So what's the equation for that horizontal asymptote? Y equals 1. Excellent. So now I want you to pass the rubber band to your partner because you got to use it last time. They're going to use it this time. Your partner is going to stretch the rubber band vertically along the left side of the graph. So it needs to be vertically. Stretch it vertically, up and down right here. I need you to move that rubber band, that vertical rubber band, I need you to move it over to the right until it falls in place of where the vertical asymptote is. So what number does the asymptote go through? -1. So if I draw my asymptote here, goes halfway between 0 and -2, that would be a value of -1. And what's the actual equation of the vertical asymptote? X equals -1. Good, because it's going through the x-axis, the x value of -1. Okay, I'm going to give you a little bit of time to find the x-intercept, the y-intercept, and if there are any holes, put those down. So I'm going to give you about a minute. I'm going to pause the video. Okay, so the x-intercept, look at your answer. I'm going to call on somebody, so look at your answer for the x-intercept. Angela, what did you get? -2, 0. Good, right there. And then for the y-intercept, look at your answer. Chris, what did you get for the y-intercept? 0, 2. Thank you very much. Okay. And then for holes, look at your answer. Jasmine, what did you get? None. Yeah, very nice. There are no holes that are in this hyperbola, so none. So the only thing that's left is to write the function. So how do you start out with writing a function? What does it start with? Huh? Not necessarily y equals, but f of x equals. So they mean the same thing, but whenever we talk about a function, we want to write f of x to show that it is actually a function. And if it's a function of a rational equation, that means we need to make it a fraction right away. This is where I want you to think about what you read in the 6-5C and 6-5D notes before the lesson started. So tell me about the x-intercept. Tell me about the x-intercept. Where did that come from?
Where the line touches the x-axis.
Yes, it comes from where the hyperbola touches the x-axis, but like in a function, in an equation, where does the x-intercept come from? How do you get it? It comes from the numerator, right? It comes from setting the function equal to 0 and solving, but really you're not setting the function equal to 0, you're setting the numerator equal to 0. So the x-intercept comes from setting the numerator equal to 0. Tell me about the vertical asymptote. How do you get the vertical asymptote by looking at a function? You take the denominator and you do what with it, Patrick? Set it equal, yes, set it equal to 0 and you solve. So the vertical asymptote is where you take the denominator and you set it equal to 0. That's from a function to plotting it on the graph. Now we're going from a graph to putting it in a function, but we're going to use the same thing. We're going to use the x-intercept for the numerator and the vertical asymptote for the denominator. Okay, we're just going to kind of do it backwards. So think about the x-intercept. The x value is at what? X equals -2. So what's the linear factor that goes along with this? X plus 2. And the x-intercept shows up from the numerator, correct? So the numerator needs to be x plus 2. We get it from the x-intercept. Okay, so we're kind of working backwards. What about the vertical asymptote? The vertical asymptote's x value is -1, so what's the linear factor that it would come from? So where does that go? On the bottom as the denominator. So that comes from the vertical asymptote. There are no holes. Where do holes occur? When the function has what happening? Common factors on the top and bottom that get what? Canceled out. So if there are no holes, then should there be any common factors on top and bottom? No. And then the last thing we need to look at is the horizontal asymptote. It happens to be 1, not 0, and it is actually there. So that means that this needs to be the ratio of the coefficients of the numerator and the denominator. So how do you rewrite 1 as a fraction? 1 over 1, yeah. Are those the coefficients for x and x? Yes. So do we have the right function? Yes, we do. Can I get a thumbs up? This was okay, you could follow it. Thumbs down, definitely not. Thumb somewhere in the middle. Let me see your thumb. Thumb, 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 thumb. Okay. Thumbs in the middle and thumbs up for the most part. That's good. Okay, so moving on to the next example. It says, what would the function be if there were a hole at -2, 0 and no x-intercept? Does this graph look the same as the graph above? Yeah, it looks the same. It has the same asymptote horizontally and the same asymptote vertically, but now it has a hole, right? Which means that in the function, we need factors that do what? That cancel out. What's the factor going to look like if the hole's x value is -2? X plus 2. Good. X plus 2 needs to be where? Yes, that's how you get this. You set this equal to 0 and you get to the x value of the hole, yes. But if I were going to put it back in the function, where does it need to be? It needs to be on the bottom and top. Sorry, that's probably not very good English. X plus 2 needs to be bottom and top on the. Bless you. That way it can cancel out and we will actually have the situation where there is a hole. So if it's the same function, but it just has a hole, that means that it should be the same equation, but it just needs the x plus 2 to be on the bottom and the top. Interesting. Okay, let's add the x plus 2's and then let's see what happens with the x-intercept, okay? Because you're right, this is important. So f of x equals, what was the numerator before? X plus 2. And what was the denominator before? X plus 1. And what am I adding on the top, or multiplying, inserting also on the top and the bottom? X plus 2's. Agreed. Isn't that the same thing as where we got our x-intercept from in the past? There's no point here, right? Because there's a hole. Right, because the x-intercept was supposed to be here, right? But if there's a hole there, then there is none, which checks out with this piece. Okay, so the only extra thing that we had to do here was add on the x plus 2's on the top and the bottom. You would if you were trying to, the question was, do you cancel out the x plus 2's on the top and the bottom? The answer is you would if you were trying to find some parts of the graph, if you were trying to find some key features of the graph. But if I'm trying to actually write the function, then I want it there so that, you know, I could like foil it back together and I could get the polynomials on top and bottom. Good questions. Okay, can we move on to the next one? Go ahead and open up. Open up the notes. Okay, before we start this one, and I'm going to let you find a lot of the pieces by yourself, so not the function, but the other 5 key features. I want you to look at the graph. The graph kind of looks like some stuff that you saw at the end of last week, where it has a hyperbola, but then it also has this little thing right here. What does this kind of look like? What type of function in the middle? Someone said it, yeah, cubic. It looks like a cubic function. But it also has this hyperbola right here. And so I want to mention something about the horizontal asymptote. Because the horizontal asymptote, if you take your rubber band and you stretch it horizontally along the bottom, and then you move that rubber band up, 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 it's going to look like you have a horizontal asymptote, but then that little part in the middle, that cubic part, is going to cross it. And we've talked before about how asymptotes don't have, like you can't touch an asymptote, right? You're never going to touch it. You're going to get very, very close approaching the asymptote, but you're never actually going to touch. And it actually does touch in the middle. The reason I'm bringing this up is because you do have a horizontal asymptote for the hyperbola part of your graph. And it is going to touch the cubic looking part in the middle. So you need to be aware of that. So if you'd like, we can do the horizontal asymptote part together. Do you want to do that part together? Okay. So if you stretch your rubber band horizontally along the bottom and you move it up, 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 what number does it seem to cross? Where does it seem like the horizontal asymptote is? Y equals -1. Good. Thank you for giving me the full equation. Y equals -1 right here. So that is the horizontal asymptote. And it does look like it touches right here. It does look like it touches. It does look like it. Yeah, that's right. Yeah. It looks like, sorry, it didn't sound right whenever I said it. It looks like it touches right here, and it does, but there's still an asymptote for the hyperbola part. So these parts of the graph are going to approach but never touch y equals -1, and this is going to approach but never touch y equals -1. So the hyperbola part is going to approach but never touch the y equals -1 horizontal asymptote. Okay? Does that make sense? Even though it touches right here, it's still an asymptote? Okay, so I'm going to give you a couple minutes or so. I'm going to turn the recording off. I want you to find the y-intercept, x-intercept, vertical asymptote, and holes. Okay, go. Okay. So I'm going to tell you what I want. Look for your answer. Stop playing with each other's hair. Quit. And then I'm going to call on somebody, so be ready. Okay, the first thing that I need is the x-intercept. Look at what you put for your answer. Alex, what was the x-intercept? -3, 0. I definitely agree with -3, 0, but you just said, oh, like your table revealed something to you. Is there another one? Yeah. What's the other one? 2, 0. That little part. There we go. That's also an x-intercept. Very nice. Very nice table for helping out. Okay. Next, I need the y-intercept. So look and see what you got. Evelyn, what did you get for the y-intercept? None? Why none?
Because it's not touching the y-intercept, it's very...
Yeah, the hyperbola doesn't touch. Like barely there. Why does it not touch? What's there?
An asymptote.
What kind of asymptote? A vertical asymptote where x equals 0. Good job. Yay. If there's an asymptote along the y-axis, then we can't have a y-intercept. So y equals 0. Maybe a volunteer for this one. Is there another vertical asymptote?
Yes.
Yes, Anna.
X equals 5.
X equals 5?
Oh, just kidding. Y equals 5.
Oh, wait.
No, yeah, it is.
Who's wrong here, me or you?
You.
Me. Thank you. All right. Good. Okay. So the vertical asymptote should be x equals 0 because it's going through the x-axis, and x equals 5 just like you said. Thank you. Oh, good. I'm glad I scared you. Gets the blood flowing. Okay. Holes. Are there any holes? No, there are no holes here. None. Which means that we're going to have no what in the function? Where do holes occur in the function? No common factors on the top and bottom that cancel out. Good. So we're not going to have that. If I'm going to start with my function, how do I start it? F of x equals, and it's a rational equation, so I'm going to draw a fraction bar. Very nice. Okay. All right, let me change my colors here. Raise your hand if you can tell me where the numerator comes from. Raise your hand if you can tell me where the numerator comes from. Mackenzie? The x-intercept. So I have two x-intercepts, right? I have one where x equals -3 and one where x equals 2. What's the linear factor when x equals -3? X plus 3. What's the linear factor for when x equals 2? X minus 2. So that goes in my numerator. Okay. New volunteer, where does my denominator come from? Raise your hand if you can tell me where the denominator comes from. Abby? The vertical asymptote. So I have x equals 0 and x equals 5. What's the linear factor for when x equals 0?
X.
Ooh, x. Good. And then when x equals 5? X minus 5. Okay. X times x minus 5. Let's check some things out. No holes means that there's no factors on the top and bottom that are common that would cancel out. Does that happen here? Do I have that?
No.
No. So is that good? Yes, that's good. It's the way it's supposed to be. And then the horizontal asymptote is not y equals 0, but there actually is one. So that means this needs to be the ratio. How do I write -1 as a fraction? -1 over 1. So are these my coefficients of the numerator and the denominator? No, one of them is though. Which one is right? The bottom. The denominator's coefficient is 1, but what should the numerator's coefficient be? -1. And that's not really going to change the x-intercept, so it's okay that I put it there. Wonderful. Wonderful. Okay. Last problem is on the back side. We're going to do some transformations, but we're going to do simple transformations. So I'm going to change this. Here we go. It says use the graph below to sketch number 3 and number 4 with the given transformations. And the transformations we're going to do are all simple. They're all translations, so shifting left, right, up, and down. Before we start, I want you to take some time with your partner and this first graph, and I want you to identify the 4 key features that are here. So I'm going to pause the video and give you some time to identify. All right. So this is what your classmates came up with. Do you agree? Yeah. So it happens that the x-intercept and the y-intercept are the same point because they cross at the origin. Here's my asymptotes. If you don't have yours drawn, you may want to draw them now. Because one of the cool things that we can do with asymptotes and transformations is we can translate the asymptotes and then figure out where the hyperbola should go. Instead of translating every single point on the hyperbola, you can just translate the asymptotes, which is kind of cool. So for number 3, it has f of x minus 2 and then plus 3. So if you have x minus 2 in parentheses, what does that indicate you're doing?
Shifting right 2 times.
Shifting right 2 times. Remember, anything in parentheses is a lie. It's also along the x-axis, which means you're shifting horizontally, so left or right. What about plus 3 on the outside? Up 3. Okay, so my transformations are shifting right 2 and up 3. There we go. Right 2 and up 3. So instead of, like I said, instead of shifting the hyperbola, we're going to shift the asymptotes because you can still kind of figure out where everything should be if you shift the asymptotes. So originally, I had an asymptote that was vertical at x equals 2. So I had this right here. But where do I need to shift this? I need to shift this to the right 2 times. So instead of it going through 2, if I shift it over 2 times, where does it go through now? 4, yeah. So I'm going to erase the old one, I'm going to put the new one. There we go. So my vertical asymptote was at x equals 2, but then mathematically, what do you do when you move to the right? So my new vertical asymptote is at x equals 4. What about the horizontal asymptote? It was at y equals 2. It was here. But how are you shifting it? You're shifting it up 3. So if I shift it up 3, up, let's see here, 1, 2, 3, here's the new one. What is it going through?
5.
It's going through 5. So I'm going to take my eraser and I'm going to erase the old one and leave the new one. Okay. Mathematically, with the y values, if I shift up 3, what do I need to do with 2? Add 3. Yeah, so my new horizontal asymptote is y equals 5. So now you can fill in the hyperbola. The hyperbola came kind of this close to the intersection of the axes. So how do I get from here to the intersection of the axes?
2 across the box.
2 across the box. Can we kind of act like slope though? Can we do like moving right and left? How many to the right? 2 right and 2 up?
Yeah.
And then how do I get back on the hyperbola?
Up 2.
Up 2?
Yeah, right 2.
Right 2. Yeah. There we go. So basically, if I move 2 over and 2 up or down, then I should land back on the hyperbola. So here, how should I move to get the top part of the hyperbola?
Oh,
From the intersection,
2 over 2.
2 over, 2 up. So here's this part of the hyperbola. And then how do I get to the bottom part?
Right 2. No, left.
Left 2, down 2. Here's the bottom part of the hyperbola. Pretty nice, huh? Okay, so with your tables, I'm going to let you do the very last one. So I'm going to pause the video. I'm going to let you try number 4. It comes from the same graph, so same intercepts, same asymptotes, but it's a different transformation. So last problem, identify the transformation with your group and try to translate those asymptotes and draw in the hyperbola. Okay, so drawn on the board are the asymptotes from the original function, and then I went ahead and I wrote the vertical and horizontal asymptote equations so we can manipulate them based on the transformation. So the transformation, think about what kind of transformation occurred. Faith, what kind of transformation occurred here? Shifting down 3. Down 3 units. So raise your hand if you can tell me if the vertical or the horizontal asymptote is the one that's changing. Which one is changing? Jalen? Horizontal asymptote is being shifted down 3. Good. So I'm going to move down 1, 2, 3. This is the new horizontal asymptote. I no longer have the old one. Okay. So if the horizontal asymptote was the one that changed, what do I do to this y equals 2? I subtract 3. So I end up with a horizontal asymptote of y equals -1. Did the vertical asymptote change? No, it didn't change at all because we didn't shift left or right. We only did a translation. So how do I find the parts of the hyperbola? Raise your hand if you can give me a way to find the hyperbola and where it should be graphed. Raise your hand if you can tell me. How do I get to the hyperbola? Yes? Right 2 up 2? Okay. Come on, pen. There we go. So here's part of the hyperbola. And then where else? Left 2 down 2. And then something that seems to be kind of important is the intercepts, right? The intercepts are kind of important. So I want to make sure that my intercepts are occurring in the correct spot. So before, my intercept was here, but now where does it get shifted? Down 3. 1, 2, 3. So that's at the point -3. The 0, -3 for my ordered pair. Did that happen here?
Yeah.
Yes, it did. And then for the x-intercept, I need something that's going to come down after being shifted down 3 times, and it's going to land on the x-axis. So I need to figure out 1, 2, 3, whoops, 1, 2, 3, where my kind of intersection is along this line. Because this is what's going to come down, and it's going to be on the x-axis. So where does that point occur? Where does this cross my line y equals 3? Let me ask that question again. Where does my hyperbola here cross the line y equals 3? Do you see where they intersect? Is it at 5? It's not at 5. Well, look on your graph. Isn't it right there? Right? 1, 2, 3. Isn't it like just after the 5? Right? Here's 5. Here's 6. Yes? No? So whenever this comes down and it becomes the new x-axis, my point on the x-intercept is going to have a x value of what? 6. Yeah. So I need to make sure that that's happened. 1, 2, 3, 4, 5, 6. Did that happen? Did it happen on yours? Can you go check it on yours? Okay.